So when I say that large language models are just autocomplete on steroids, I have to admit I feel a little bit guilty because I hate this metaphor. It's technically true. It's just viciously reductive. It's like saying the Mona Lisa is a collection of oil on white poplar. It's correct, but it misses everything that makes the Mona Lisa a masterpiece. And the thing about autocomplete is that you have a pretty good idea of how it works. It does give predictions, and it can make a pretty good guess at the next word because it's been trained on a bunch of text messages that people have sent in the past, and it's paying attention to what you're typing. It's got something like a spreadsheet that shows correlations between what you've just typed and the likeliest next words or phrases. And it's paying attention to what you've just typed. So if you type in New York, it knows that 90% of the time people do that, the next word that should pop up is going to be city. So you've got two elements here: training and context. That's the whole system. For autocomplete, training is that spreadsheet, and context is just the things that you're typing. Hold on to those two words because those are the two basic ingredients that ChatGPT, Claude, Gemini, all the rest of them require. But you may have noticed that ChatGPT can do a lot of things that autocomplete can't do. It can make arguments, invent stories, write poetry, solve math problems, translate ancient Greek. It can debug code. It can explain your feelings back to you. How does a large language model do that with nothing but training and context? Why is it so much more than just autocomplete? The question is, what happens when you scale those two things up to something that's almost impossible to imagine? In this video, I want to talk specifically about training at scale. Autocomplete trains on something about the size of a pretty big spreadsheet. But large language models are trained on terabytes of data scraped from the internet. Novels, Reddit threads, medical journals, legal briefs, arguments on Twitter, bad poetry on Tumblr, brilliant philosophy in academic journals, and on and on and on. You take all that data, and just like with autocomplete, that spreadsheet, you just go looking for correlations. And here too, we find that New York pairs with city. But since you have so much data, you can get back this enormous table of correlations. And that means that you can find subtler connections. And someone had the bright idea. What if we took all these correlations and put them on a map? Give each word a point in space. And then what if we indicate how close the words are with a number, a kind of distance, denoted by a number so that the closer correlations are actually closer in space? When you do that, you see not only that king correlates with man, but that it correlates in roughly the same way, separated by the same distance that queen correlates with woman. This correlation isn't there because the programmers told it to be there. It's there because the models found those statistical relationships in the data. And king, queen, man, and woman aren't special. Every word in the data set gets placed on the map. So look, there's Tokyo sitting by Japan in just the same way that Paris sits by France and Rome sits by Italy. Those little arrows seem to mean something like, is the capital of. It's a different distance in a different direction, but it's basically the same trick. And that trick's everywhere. King to prince, queen to princess, man to son, woman to daughter. The correlations are all over the place. Of course, if we're using all the words in our data set, this page is going to get very crowded. Every word needs to sit near everything that it's related to. 2 dimensions just isn't going to be enough. To give you a sense of the scale, The first model of ChatGPT was trained on data roughly the size of Wikipedia. The fourth model surpassed the entire Library of Congress. It's something like 300 times more data. And we don't even know how big the latest model is. When you talk to ChatGPT, you are, in a meaningful sense, interacting with a significant portion of everything that human beings have ever written. Now imagine doing that not just in 2 dimensions and not just in 3, but in hundreds of dimensions at once, in a space so complex that humans can't really visualize it, but computers have no problem keeping track of. And instead of just mapping one word to another, map each word to every other single word in the corpus. 1,000,000 words in English, each mapped to 1,000,000 other words. That's 1,000,000,000,000 little weights just for one language. You feed the model all of that training data and you say, figure out where every word should live in this geometry, based on everything it tends to appear near, across every document that we've given you. When you do that, something magic happens. You get this unimaginably complex map of the relationships all the words have to one another. And at that level of complexity, patterns start to emerge that don't just look like statistics, they look like meaning. Or at least they look like the statistical shadow that our meanings cast in the things that we've written. Even if you don't tell the model what kinship or places or royalty actually amount to, it will cluster these kinship, place, and royalty concepts together because that's how they show up in the statistics. You end up with a geometry that echoes the shape of human concepts.